Welcome to this webinar about capital projects, CAPEX projects, big and small, several of them to do with modifying factory layouts of machines and that sort of stuff, and done with the critical chain approach. My name is Marris. I'm English. I consider myself European. I'm bilingual. I live in Paris. I'm a horrible consultant. I began my lean journey in 1984, and a little bit later I discovered the theory of constraints, and I've been mixing those two things together to improve the performance of organizations for over 30 years now. I founded Marris Consulting. Marris Consulting, founded in 2005. We've had the pleasure and honor of serving a certain number of companies, and it's kind of hard to say what we do or don't do because we touch nearly any physical product. So cars, trains, planes, rockets. So what is critical chain? It's a technique that's now over 20 years old, and it's all about planning and executing projects differently in such ways they go faster, you finish them on time. And all. The quick description is the following. Traditionally, when you have a project, which in this case I've broken down to a very, very simple, simplistic example of 3 different tasks, you have to estimate the duration of each of the tasks. And so you go and see the first person who's doing the first task, you ask them how long it's going to take to do their task, right? So the first person would say it might take them 4 weeks. The second person doing the prototype would say, oh, I think it's going to take me 16 weeks. And he gets to the last person who, for his task, is going to give him a duration of 12 weeks. In each case, what the person was asking is, when can you commit to having finished? Okay, that's the traditional way you do it, right? How long is it going to take you to do this task? Okay, and in fact, if you do it that way, according to the reasoning of the critical chain, you've already killed your project, right? Because if you do that, you're asking people to give a number, a date, in an uncertain environment, and so they're going to add safety, local safety, to each of their tasks so that they can meet their commitment. Critical chain does things differently. It asks people for 2 durations. One of them is a focused duration, and the other one is a pessimistic duration for a given task, right? In this very simplified example, let's assume that half of the time is focused duration and another half is the pessimistic duration, right? In planning, you keep the focused durations only, right? So you plan for this perfect world where everything's going to go perfectly well, no big problems and stuff. But since you know that's going to be impossible, you add a buffer to absorb all the problems you are going to have, and this buffer is big, huge. It's about 1/3 of the duration of the project. Okay, and to execute, you use the iconic fever chart, where along the horizontal axis you have the execution of the project. Okay, from the beginning to the end. Okay, and along the vertical axis you have the consumption of the buffer, right? And you consume the buffer. That's perfectly normal. That's what it's there for. Okay. And you get worried if you get up into the red zone, as we have here, right? Because if you get up into the red zone, it means that if you carry on this way, you're going to go up here, right? And you're going to finish up somewhere like that. And that means you're going to be late. You're consuming your buffer too quickly. So you have a look and see what's happening. You find a solution, you accelerate, and off you go. You finish over here, for instance, which is finishing early, right? What you promised your client or you promised your boss is up here, top right-hand corner, with a buffer consumed. Okay, so you plan to finish early, and that's how you get to these strange results where people are finishing 100% of their projects on time. It's because they're all aiming to finish them a little early. Okay, and that might sound strange to you, but that is in fact already how everybody gets on an airplane, right? You do not miss your airplane. You end up waiting in the waiting lounge just before boarding when you have nothing left to fear. And that's how you ensure that you don't miss your airplanes. Okay, so that's a very, very brief presentation. If you want more, there are lots and lots of presentations about how this works in more detail. For example, there is this series of videos that I've done. Each of them is 20 minutes long. So let's dive now into examples. I'm just going to give you a series of examples. Okay. CAPEX, all CAPEX, large and small. This one's large. There's a person here. Yeah, there's a person here. That's the ore-crushing machine in the gold mine of iron gold in Burkina Faso. Why is critical chain pertinent? Well, CAPEX, whether it's modifying plant layouts, you can have several of those, installing a big new machine or a new production line, moving production lines from one factory to another, from upgrading or modifying a series, a whole set of production lines. You'll see some examples. These are all these sorts of projects. This is what we're talking about, right? Okay. Why is critical change pertinent? Well, because as you'll see, you can make these projects go faster, about 20% faster, or 80% faster. Okay, a classic of critical change. We're averaging sort of about 50% reduction, about twice as fast. Okay? It takes into account the specific constraints that we find in these sorts of CAPEX projects, right? Unreliable suppliers, co-activity and space constraints. I can't do that at the same place here because it's dangerous. I can't do electricity and welding in the same spot. I can't do that because there's a safety issue. And I have to manage subcontractors. All these sorts of things can be properly modeled. The other point is, by the way, that nearly all these examples are in fact a succession of two different projects. The first prepares the investment, and the second executes the installation. Here is a case which has been presented because it's about 5 years old now. And it's here because it's basically what kicked off within Marris Consulting a whole series now of CAPEX investment project run critical chain way. It's the maintenance manager in a factory we were already working with who decided to do it himself. And he got these extraordinary results, right? The plan, it was initially 8 weeks and it took 6.5 days. It's a 400-person factory. They moved 45 of the 52 machines. These are machines that some of them are only 300 kilos, but some of them are 10 tons. They wanted to put the machines more logically together, according to have families of products produced together. A classic, right? They'd been installing for 30 years. They've been installing machines where there was room, right? And so the material flow in the factory was just a horrible spaghetti diagram. So initially it was 8 weeks, and they got it down to just 6.5 days. They did it using critical chain. How does that done? Well, you model the work to be done, right? These are the different tasks that have to be done. This is how long they're going to take with two durations, right? Focus duration if all goes well, pessimist duration if I have problems. What resources do I need? Resources, human resources. I need the people, I need an electrician, but also eventually material resources. I need cherry pickers, I need a crane, so you can model the resources that are needed. And you do a lot of optimization, right? Because this in this particular example, maybe the optimization is the most spectacular. The first time he plugged in and did his model, it did take 8 weeks, right? And so he had to work and work at it and see what happens if I do it this way. What happens if I rent some more cherry pickers, which he did, right? He went from 1 cherry picker to 4 so that they could move faster. And he did that continuously, and he said, "This is not going to fit. I need to do it beforehand." Okay, this concrete thing, I'm going to do it before I start because otherwise it's going to get in the way when I'm doing it. He did this, and then when it was executed, it went at lightning speed. A lot of discussion was with all the people involved, right? Both the workers who were going to do it, the teams involved, the subcontractors doing the various bits, and a certain number of stage clearly identified. At this stage, we're going to have these machines done. At that stage, on the second day, we're going to have that done. On the third day, we're going to have that done. So forth. Everybody agreed with the sequence, and of course, big focus on the critical chain. Okay, and for those who don't know, this is an example of a real critical chain execution. Right, they had a problem here on at this stage. Right, they lost over a day without moving ahead. Okay, but they finished a little just before the top right-hand corner. The top right-hand corner wouldn't be in 8 days. Okay, you don't want to take my word for it. There are a number of videos by the people who did it, right, from Safran. Guillaume Bretenoux was the guy who we should all take our hats off because he was the one who made this possible. Change of continent, Africa, Burkina Faso, a gold mine with several thousand people working in the middle of the desert in northern Burkina Faso. A big investment to increase the capacity of the gold mine, multi-million. And just as they were starting to get the procurement done, that's to say, you were getting all the stuff from all over the world, right? Some parts came from Germany, some parts came from Sweden, some parts came from India, some from Brazil and stuff. Everything had to come from all over the place, and Japan and China and whatever. All the bits and pieces had to come from all over the world through shut down harbours and difficult customs environment, and then up into the desert in the north of Burkina Faso, right? It was a big problem. given the first lockdown, which was happening right then. But they did that using critical chain, and they couldn't afford to have the factory closed down too long. Okay? So here they did it, as I say, 2 projects, one to prepare, make sure they had all the parts on site before they started the work. Okay, so using critical chain purely throughout all the different logistics of all the key parts coming from all the different countries. They model it, it's going to take so many days of boat, so many days to get through customs here, so many days to get on the train here, so many days whatever, and also pessimistic and optimistic durations, fever chart, piloted and stuff so that they could see what was getting late and stuff. And then they used critical chain again, okay, to execute. In the top case, it was over several months with a weekly check. On the second one, down at the bottom here, it was day by day, hour by hour, and typically you would have things like a 72-hour planned task with 56-hour focus duration. It took a little bit longer and ended up at 63 hours. All this sort of stuff, right? As they went through. And here are the fever chart, okay, with all the good news, the bad news, and all sorts of stuff. And it happily finished. With little, not much buffer consumption, and therefore ahead of the committed time. Again, more videos available by Safran, you can see here. This one here is a pharmaceutical industry in France. 2 different implementations of critical chain. One on their largest factory investment, completely modifying their main production line. With a multi-million-dollar investment, with a new packaging line that was a much higher capacity than the old one, okay, and another usage of critical chain where they had to upgrade a series of 12 production lines. I'll describe that in a second. Okay, the big new packaging line was going to take 6 months, and the modifications on each of the 12 lines was going to take 3 weeks each. Okay, and it was judged to be too long. Okay, so they wanted to do these things faster than that. So the new big line was done with critical chain. It was remodeled, replanned, optimized to be 4.5 months of focus duration and 1 month of buffer. We also used in this particular case a mascot, which you'll see detailed in the videos I mentioned. It's something that you can use during execution, since the critical chain, right, the sequence of tasks that will determine whether your project finishes on time or not. The close cousin to the critical path, if you wish. You can it's only at one spot at any one time, and so you can have a big physical remarkable object go down that chain of events, and that's what they did. So whenever they saw this big panda thing, everybody knew, keep out of the way, this is the critical part of the project. They're the ones who are going to define if it's a success or a failure. Okay? We use these mascots a lot. A physical thing that follows the critical chain, so everybody knows, watch out, that spot there in that office there, that is the critical chain. Okay, it focuses everybody's attention, and you have this example here of their fever chart. They thought they probably would have taken 9 months if they hadn't used critical chain, because this happened right in the middle of the first lockdown of the pandemic in Europe. The other thing they did was this series of production lines that they were all modernizing. It's in pharmaceuticals. I don't know, for those who know this business, there's a serialization project going out throughout the world to reduce fraud. You have to put up a specific serial number of each individual packaging box. So that's what they were doing. They were installing printers on all their lines. The initial plannings were for 15 days. They put them all on the critical chain. You have here the initial duration, the critical chain plan, and what was the actual. And as a result, they reduced the durations by 24% here. Again, many videos are available on our website about this case. There are half a dozen, I think, by various people. To conclude, what can I say that sort of lessons learned about doing all this? Well, as you can see, that it works, and it's in fact quite simple. It's fairly basic. You just apply the principles of a critical chain approach. Right? There's no specific magic. The things to note are, I mentioned it initially, and we find that it's frequently useful to, in fact, have 2 projects when you're doing a CAPEX. One which is to prepare it, and one which is to execute it. Right? I cannot emphasize to what extent preparation is important. It's true in critical chain in general, right? Because you're going to actually execute the plan, and therefore you should spend a lot more time preparing, making sure you've got everything, you've thought of everything, you've got all the resources, you've got your full kit, and so prepare. None of this could have happened if it hadn't been properly prepared, right? The optimization of these schedules is absolutely key. playing around, because you know that the project will be executed according to your plan, right? So it's worth investing time to see if I can't change the sequence, do this, add a person, add a machine, do something different, okay? And also, we often use, I don't know, this is the right analogy, but let's call it the SMED principle, single minute exchange of die, right? Are there things that I can take out of that project and do before, in particular civil works, the concrete drying, all that sort of stuff? Maybe I can do that before I start. If I change the way I do this or that, maybe I can speed up that task with better tooling or a different way of doing it. Okay? An obvious thing, nothing to do with critical chain, but if you want these sorts of projects to happen correctly, you really need to get people who are on the shop floor involved, of the suppliers as well, the subcontractors. Everybody's going to be concerned to be involved in designing the plan, and of course in discussing the execution, looking at the fever chart every day and whatever. Okay. And for the shop floor layout ones, another little trick we always use is have a daily image of what the target is going to be. On Wednesday, we should have that machine there, that machine here, that machine there, that machine there, and stuff, so that you know where you're heading. Okay. And just to conclude, the results are unbelievable, would you not say? I mean, when Guillaume did his 6.5 days, I didn't believe it was possible. In fact, I mean, I knew the factory well, and I didn't think you could do that sort of thing in 6.5 days, which seemed too much. But he did it, right? So that's given us ambition to keep trying to speed up these things, and we're getting lots of fun, very fast results. Okay.